Okay, so I'm going to start this recording, and this video is going to be about the elements of quadratic functions, and more specifically, their graphs. And so what I've drawn here is just a generic upside-down parabola. And I have here written vertex, and this isn't perfect, but the vertex is this point right here. It's either the top of the hill or the bottom of the valley. So in this case, we're dealing with the vertex that's the top of a hill. Now, this quadratic function, this opens downward. And this is important for when we get to some other elements. But for now, the vertex is right there, and I'm just going to say that this is about, let's say x is equal to 2, and y is equal to 4. Okay, that's what this point is right there. And so when you're talking about the vertex, you just list what that coordinate is, what it happens to be, either the top of the hill or the bottom of the valley. Now, there was another element that we looked over, and this is a little trickier. This is called the, I'm going to abbreviate it, but the axis of symmetry. And what the axis of symmetry is it's this imaginary line. We don't draw it here, but if you were to take a parabola is symmetrical, which means that it's this, if you cut it down the middle, it's identical on both sides, and it can fold on top of itself. Now, if you see the axis of symmetry really only ever covers one x point. It goes up forever, but it never moves from this x point. And so I had tried to tell you that a shortcut, a way to memorize how to write the answer for the axis of symmetry is just look at the word axis. And there's an x in it. And so your answer for the axis of symmetry is an x equals, and it's just equal to this point right here, the x coordinate on the vertex. Okay? Now, moving on, I'm going to hit two more things, and the second one the third thing I'm going to hit is this concept of domain. And domain is the solution for all x values in this function. Now, for quadratic functions, your solution is always going to be this, negative infinity to positive infinity. Now, this is not a coordinate point. It's a description of left and right. How far left will the graph go? Well, it's always going to go left. It's going to look like it goes straight up and down, but quadratics are always moving left, and they're always moving right. That's what those arrows show. So domain is easy. And the last bit is range, and range gets tricky because it's a description of up and down, but once you have your vertex and you have your picture, you don't need the picture. If you had the equation, you can know whether you have a hill or a valley just from the leading coefficient. But in this case, let's look at our range, and I'm just going to draw something that I saw when we went over last week, when kids were describing the range. They drew something like this, which is essentially saying it starts here and it goes down forever. Well, how do you write down forever? And down forever is this right here, negative infinity. It's decreasing forever. You can just look at the arrows and see that. And the other tricky part is, where's the ceiling? That's why I have this little notch right here, because that's a ceiling. If I drew this here, there's no it's not the same as the axis of symmetry, but it's a ceiling. It can't go above that point. And we use the y value in the vertex to actually figure that out. And so once you have the vertex, you have all of your information to answer this series of questions. And the last thing about the range is to say that it includes 4. We don't use a parentheses. We use this bracket to close off. So it goes down forever, and then it stops. Its ceiling is at 4. And so that's how you do these types of problems.